in between gigs, I do like mad science and get myself into shenanigans, and today's talk is a product of both of those things. So today we're going to talk about building decentralized systems in Node.js, and what that means is we're going to be taking systems that look like what you see on the left here, where there's a single point of failure, and re-engineering them in such a way that there is no single point of failure, they're highly available, and ideally peer-to-peer, so it's not actually a single point of failure with your infrastructure. And we're going to do that in Node.js. So first, why would you want to do this? Why would you want to build a decentralized system in the first place, and why would you want to build it in Node.js? Considering this audience, I have a feeling that there are some people here that have some really strong opinions about that second point, so we're going to dive into that first. Why would you want to build these kinds of systems in Node? So I'm not quite sure if there's a technical argument for why Node is the best for decentralized systems. It's like not provably correct like some classes of languages like OCaml. It's not really great at CPU bound work, like languages like Go and C. But what it does have, and the argument that can be made for Node, is a people argument, right? And that is JavaScript. So JavaScript, by every metric, is the most popular and most known programming language that we have today. If you ask any developer what programming languages they know, they're going to give you a handful of programming languages and JavaScript. We all sit somewhere on the spectrum of document.write and understanding the prototype chain. We all speak this language. So when we build these systems, these decentralized systems in Node, we build our libraries and our building blocks for working with these systems in Node. We take these systems and we put them in as many hands as possible to build the most powerful systems on this planet. And that's important. And Node has something that no other programming language has, which is Electron and the power of Electron. So we're going to make a case here for why you would want to build decentralized systems in the first place. But I think it's a little unreasonable to expect that everybody on this planet is going to write code every day. Even more so, all of those people are building decentralized systems. But I do think it's a reasonable expectation to believe at some point in time, everybody on this planet will be using a computer in some way. And the idea is, if we build these systems and we build them in Node and JavaScript, and we have the largest possible audience of developers building these systems, we can then take these applications that we're building, and we can put beautiful web UIs on top of it. And this will let us as developers take these systems and put them in front of people who have no idea how to use computers beyond interacting with a simple web browser. So it makes not only the technology itself accessible to developers, but technology accessible to the people who are consuming the products that we're generating. So the case for Node is here. But why would you want to build a decentralized application in the first place? Well, usually when you ask this question, the response is something along the lines of this. It's like power to the people, new world order, like resist tyranny, et cetera, et cetera. And there's a lot of truth to this argument. I'm not saying there's not. But there are other narratives here and other narratives at play and other really powerful reasons why you would want to build this technology. The first set of, or the first story that I want to share, our first narrative is a business narrative, or the business case for decentralized systems, specifically the business case for peer-to-peer systems. So when you're building these systems and peer-to-peer systems, you're able to have your clients not only be consumers of your applications, but actually contribute infrastructure to your application. So you can offload non-IP data, non-IP business logic off to clients, and they can help actually contribute uptime and reliability to your system. So by building systems like this, like your update servers, pushing those out over BitTorrent, what that lets you do is be an initial seed in a global network of updaters, and your clients can help or update each other, and all you do is you act as a verifier, making sure that the updates that they're receiving and downloading from each other are valid. But I think there's an even more powerful story here. Beyond just the business case and reducing server costs and making our programs and applications more reliable. So we're in New York City. I don't think that's a surprise to anybody. And me personally, I live in the Bronx. I'm up at the end of the 1 train in a community called Riverdale. And we're at the top of this really tall hill. Our apartment building sits there. It's 14 stories tall, and we look out across all the other buildings, and we have a nice view of downtown if you go up to the roof. And every once in a while, I'll pour myself a really nice glass of whiskey and grab a cigar, and I'll go out there and I'll look at the city. And what I like doing is I like counting windows. And that sounds really weird at first, but like I'll count windows and I'll look at, it's an incredible number of windows in this photo, like that one and that one. And I like to think that for each and every one of those windows, there's at least one computer. right? And when I say computer, I use that loosely. They're between like laptops and cell phones and wireless routers. I think a lot of us don't really have an appreciation for just how powerful these things we're carrying around with us are. So this is Deep Blue. This was a supercomputer back in 1997 that broke new ground for humanity. This was the first supercomputer to beat a grandmaster in chess. And it worked, and it did that with the muscle of 11.38 gigaflops, floating point operations per second. This is a Samsung S6 released in 2015. We're carrying supercomputers around in our pockets. That's an incredible thought. These things are incredibly powerful. We may not be tapping into them 24/7, but they're capable of incredible things. And not just our cell phones, but more than likely, the Wi-Fi router you have at home has more computational power than all of NASA did in 1969. And that says something important, because 1969, with that limited amount of computing power, NASA was able to do all the simulations necessary, all the guidance computers and the rockets necessary to put humans on the moon. And we did that with less computing power than the Wi-Fi router you have at home. So when we look at this photo and all of these windows and we think of all of those computers and all of that computational power that's just sitting here on this tiny little island in the United States, and the fact that it's all just sitting there idle, kind of sends shivers down my spine, right? There's a lot of computational power here, and the kind of problems that we can solve if we tap into this is the kind of computational power that could eradicate diseases. Like, this kind of power is what wins wars. This is the kind of power that prevents wars. So we could radically change society with this class of technology if we could just tap into that unused computing power. So that's pretty cool, right? Building this kind of technology has radical implications for our society. So we are like, at this point, I'm personally inspired and I want to sit down and I want to work on this. I'm excited. Where do we start? When you dive into this stuff and you start following this rabbit hole and you start looking for resources to learn and actually get your hands dirty building these applications, eventually somebody's going to recommend something like this. This was recommended to me as a place to start, learning decentralized systems. And these are great. They teach you the theory and the actual, like, how these things are implemented on the back end, how these protocols are built, how these tools actually work. But you find yourself on page 4 or 5 telling yourself, like, yeah, these are words and there are some symbols on this page and I understand what some of this means, I think. But I have really no idea what's going on. And you reach the end of the paper, the 3rd or 4th read through, and you actually have a pretty good understanding of what's going on in the system. But when you sit down in front of the keyboard, you don't have the slightest clue how to actually, like, what's the entry point to the network? What IP address do I have to hit to start building out the graph? What's the actual protocol? How do I need to pack bits into this in order to get it to work? You don't have the slightest clue when you reach the end of the paper. And the problem with this is, if I asked you to build something like a REST server or a web server, right? A simple REST API, you would not start here, right? This is not where you would begin. You would require Express. And that's what today's talk is about, is getting the right building blocks in front of the right people for us to build these systems so these actually become a common part of, like, a normal part of our life and not an exception. The building blocks. Oh. And the first of these building blocks that we're going to talk about is WebTorrent. WebTorrent is by far my favorite Node library. Inside and out, the code inside of it consistently makes me happy when reading it. You find really cool little snippets of, like, really clever code that you're like, really changes the way you develop. But beyond that, the API itself just takes something that's incredibly complex and makes it super simple to consume. And that's what we're going to start with. And this is just like Express. You get access to the entire BitTorrent protocol by requiring in WebTorrent. Actually, it's to actually spin up your own BitTorrent client and download a file inside of your application from the network. This is all that's necessary, and that's actually what we're going to do right now. And we're going to jump down into some live demos. If anybody has questions or comments or cheap shots while we're doing this, feel free to speak up. So can everybody read this? Cool. So this first demo is a little more complicated than it needs to be, and that's because all of these technologies, while there are ways to get them to work offline, and they're actually really powerful ways to get them to work offline, the idea was to make these as simple as possible. But I wanted at least one demo to work for you guys, so I've Dockerized everything to do a BitTorrent network, and it's going to run locally. But we're not going to worry about any of that, so there's a lot of magic happening here, but all that really matters is demo.js. Sorry, new laptop. I haven't gotten all the kinks out of my Vim config yet. The first and last line are just a hack to get it to work with the Docker network. It waits for all the other stuff to come up before it actually spins up the client. But what's really important is lines 7 through 4, or well, sorry, 7 and then the 4 lines below that, 7 through 11. What we're doing up here at the top, WebTorrent, require in WebTorrent, and then in the first 2 lines between that, requiring in WebTorrent, and then instantiating a new WebTorrent, we've created a BitTorrent client that's ready to download and seed data, right? Next, we're going to create declare a magnet file. This is raw text. There's nothing really special about this. This is the unique ID of the torrent that you're wanting to download from. And when you create a seed, so when you seed a file, you're actually given this. This isn't something you have to make. It tells you what you need to share with other people in order to download it. And then from there, all we do is we client.add that file, and we say, hey, when it's ready, the torrent's ready to use, hand us or call back this function. And then we're given an array of files off of that torrent. And these files are the files that are currently being downloaded by the BitTorrent client while we're using it. We're going to take that first file, we're going to create a read stream. So as it's downloading, it's going to stream data to us. And then actually the client, like the BitTorrent client itself, is smart enough that when you create a read stream from it, it automatically prioritizes the blocks for that file, and it downloads it faster than the rest of it. So you can actually do things, crazy things like streaming video and stuff. It just makes it work. We're going to take that file, create a read stream, and if you guys haven't used streams in Node, look into them. They're freaking awesome. We're going to take that stream, we're going to pipe it to standard out. That's all it's going to do. So we're going to download a file, and we're going to write the contents of that file to standard out. So I'm going to run make, and it's going to do all the magic of building the Docker files and everything else. And it should start them. And then after 2 seconds, it'll actually start downloading. And there it is. Hello from BitTorrent. Thank you. That's probably the most interesting demo tonight. But that's how simple it is to take the BitTorrent protocol and put it into your Node app. So this can enable things from like sharing updates across all of your applications where your update server is just the initial seed, and then your clients actually propagate that update across all of them, or share that update across themselves, to incredibly crazy things like the web browser I'm going to demo later. This can empower all of that for your applications. But there's an interesting thing in this that you didn't see with the magnet file. The magnet file was a hack to get it to work with Docker. But what this is a torrent hash, and it's a unique identifier for a torrent file. And the way it works is BitTorrent has this thing called the DHT. It's a distributed hash table, and it's exactly like what it sounds like. It's a distributed, decentralized hash table that works over peer-to-peer. So if you guys have ever worked with a hash table data structure, it's exactly the same thing, but it's shared across a bunch of nodes. And the way this works is something called a CAD Graph. And CAD tools exist in Node. You can actually, there's a GitHub repository for CAD. And you can go out there and you can actually build your own decentralized applications on top of distributed hash tables without actually having to understand too much of what's going on underneath. And there's a bunch of tools that people have built on top of that, like Quasar, which is PubSub. So if you guys have done anything like Apache Kafka, like message subscribing and publishing, it allows you to do that on a DHT. Just in the box you require, or out of the box you require it in, and you have that functionality in your application. And we're not actually going to demo that today, but what we are going to demo is something that was built on top of that, and this is storage. And storage is something that you can use in your applications today. It's a persistent data store or a blob store. And you can think of storage kind of like a decentralized S3. It's not really doing it justice because it's so much more awesome than that, but what it allows you to do is, as a user, you can take all that unused hard drive space you have on maybe your desktop at home or your DigitalOcean droplets, and you can actually auction it off on storage network. And the storage network lets users upload blobs like S3, and it'll take that blob, break it into a bunch of tiny little chunks, hash it all, and then encrypt it all, and distribute it out and sell it off to the highest bidder, and then you're storing your data on this massively decentralized network. You can store like petabytes of data on there and get it back off, and it's fantastic. And it's actually super simple to use. And to make it easier, what they've done is they've created something called a bridge, and you can actually run this yourself. They're running one for the community that you can actually use on their servers. It's called HTTPS, the API.storage.io. And what it is it allows you to enter into the network with simple HTTP requests. So you can post and get files over HTTP, and on the back end, it does all the negotiating for you. And you just, every month, they'll bill you your micropayments and pay out the micropayments for you. But what we're going to do here, we're going to do exactly what this slide shows. Let me exit out of this. All right. So there's some other stuff that we had to do before. Oh, this is the our HTML file. Actually, that's the file that we're going to upload to the storage server. So this is like if we wanted to like actually host a website, but we didn't have any file or like no file system at all. That's not really possible. But if you wanted to host a website off this, you could actually host large blobs or stream video off the storage network, and you could upload it there and then set up a web server that fronts it and streams it out to your clients, and you wouldn't have to store all that on a hard drive locally. But what we're going to do is we're going to upload. And there's been some stuff that I've done before this talk, like register a user on that bridge. So you have to have like an email and a password. And then using that, you're able to do a private key, or public key pair to actually do authentication. And I've already gotten that key and everything else. And you can see that here on line 6 through line 9. I require in that private key, and I'm not going to share that with you guys because that's actually my private key, and you could actually upload stuff. But here at the first line is where the magic happens. We require end storage, and from there that gives us access to the storage bridge. So we don't have to think about the fact that we're interacting with this decentralized network. All we have to model it as is a simple web server that we're hitting and requiring or uploading and downloading data from. So we're going to hit that API. We're going to first create a bucket, and a bucket is just a place that you can put files. We're going to create a bucket named awesome sauce, and then some random characters or random numbers after it because buckets have to be unique, and I keep running this. Client.createBucket. Then we create a token, and the token just gives us permission to upload it. And then at the end of that, we're going to store the file in the bucket. Now this is the first demo we've done tonight that actually requires network. So we're going to see if it works and if it works in a reasonable amount of time. But right now what it's doing is it's reaching out to the network, creating a brand new bucket for us, getting a token that gives us access to that bucket or to that upload, and then we're going to use that token to upload that index.html file. And it should report to us at some point, and we'll give up here in just a second, report back to us that the file is uploaded. So we are going to possibly give up on this. We're going to write this off as either the network's not working or the system administrators or the network administrators are doing their job and not allowing me to do a bunch of decentralized network activity. Oh, there it is. Very cool. I guess they can unhear that. So we've uploaded a file to that bucket, and we've been given back a unique identifier that we can use to later serve that file. So this essentially is like an S3, like I said, but entirely decentralized, no single point of failure removed, and you're able to use this in your application today. So because of time constraints, I wish I had an hour, and I would have loved to go through a bunch of building blocks, but instead of doing them all up here in front of you, what we've done is if you guys haven't used Awesome Lists or seen Awesome Lists before, you should absolutely check them out because they are awesome. Aptly named. If you go to github.com/retrohacker/awesome decentralization, it's a mouthful, but there's a list of basically building blocks like what we presented today for broken out by languages, Node.js, Go, etc. So if you wanted to get up and run with decentralized tech like Bitcoin, blockchain tech, these decentralized storage options, you can actually require them in, and you don't have to understand the underlying components, or at least not intimately understand the underlying components, but you can get up and running with them today and build applications with them today. Oh, wrong way. All right, and now what we're going to do is the second half of that case for Node, which is Electron, and making applications accessible to the end user. PeerWeb is a project that I'm personally building, and it actually uses WebTorrent, which is the first thing that we presented. It's a web browser built on top of Electron, and it uses, for the UI, it's entirely JavaScript, CSS, HTML, and the rationale for that was the code base is meant to be approachable. And since JavaScript is the most spoken language, I felt kind of wrong throwing in frameworks in there where you have to learn the framework before you could understand what the code base was doing. And while I personally love a lot of the frameworks that I use on a daily basis, I decided to go down the path of trying to build this in as pure of JavaScript, CSS, and HTML as possible so as many people could understand the code base as possible. So let's exit out of this. We're going to start PeerWeb. All right, and can everybody see that? Cool. All right, I'm going to SSH into a server. And in the short term, the plan is to actually have this be something you could just do directly from the web browser. Oh. There we go. So I've downloaded cadtools.github.io to this laptop, or to this DigitalOcean server. and do web torrent seed. Let's see if I actually. Web torrent seed. cadtools.github.io. We're going to create a torrent of that directory. It's just a static website. And the big purpose, or like the big point of this is that this technology shouldn't be intimidating and it shouldn't be impossible. We're going to stop it real quick so I can grab this. Copy that. And now we're going to do it again without all of that craziness. I run Linux, so I have to do crazy things sometimes in order to get stuff to work. It's not really this complicated if you run it from your laptop. All right, so the whole point of this is that you shouldn't have to understand anything about decentralized tech in order to publish a website to the decentralized internet. You shouldn't have to think about, oh, my website is getting published to the decentralized internet, so I have to require in these JavaScript libraries and hook into these points in order for like the browser to understand what I'm trying to do. So this is an entirely static website. It's actually deployed to GitHub pages. I can go over here, and all I do is I prefix it with the peer protocol. And I've published that in there, and then the future work is going to include, so there's our static website. It works, or fully works. We can actually do search and stuff across it. So I could do like search for the UDP protocol and CAD tools. That works. Future work is going to also include a DNS lookup so that people don't have to do this, and you could just use DNS, or so some form of decentralized DNS lookup. We're still working on what that's going to look like. But one of the big points of this is that this should be approachable to anybody, from developers and any caliber of developer. They should be able to use and deploy to decentralized tech without actually understanding what's going on. And it should also seamlessly bridge between current centralized technology and decentralized technology. So in this case, what we're going to do is we're actually going to go to GitHub, and it's going to bring us to GitHub. So we can actually seamlessly go from the decentralized web to the centralized web and then back again without context switching, which means to the end user, they don't actually have to care about any of this. They don't have to understand, like my grandmother doesn't have to understand that she's like downloading this website from thousands of people, and that when she downloads it, she can also upload it to thousands of people, and she's helping keep that website up. She just plugs or goes into the browser, clicks the link I sent her, and bam, she's on my website. So that's the magic. And with that, thank you. Follow me if you have any questions about today. Yeah, follow me, DM me. We're all in this together. Happy to help. Thank you. Yeah.
So this is really about building decentralized web applications, right? Not necessarily applications that are not built for the web, built for applications.
Actually, so the PeerWeb browser is 100% for building like websites. Like so you can serve your own web content on a decentralized network. WebTorrent works in any backend node service. So this doesn't have to be public facing. A lot of my scenarios bridged current centralized tech with decentralized tech, because that's usually the path of least resistance when adopting this technology. We take our current web servers and the way they're seeding, and instead of using S3, we like decide we're going to use storage and serve from a decentralized backend. But that doesn't have to be that trajectory, right? A lot of the stuff, it can be used for just about anything, both storage and WebTorrent, along with everything else on that awesome decentralized list. It doesn't have to be web tech. Does that make sense? Yeah. Yeah. So that hash is actually a hash on the decentralized hash table, and the way it works is I actually have some mad science that shows, actually helps you understand this a lot more, but it's questionably legal, so I may not demo it here. Essentially what it is it's this network. It's a distributed hash table, and you can publish hashes and subscribe to hashes. But there's also something called Quasar, which is an algorithm for doing like pub sub on it. And one of the things you can have is announcing peers and discovering peers. And that's how it works. So you take the torrent hash, which is what you see in there, which is a hash of that torrent file. And you publish it there, and you say, hey, I have parts of this. And then other people can find your address on that decentralized hash table, and they say, hey, I'm looking for people who have this file. They can look you up by the hash of the file they're looking for. And then it identifies all the IP addresses of the people are seeding, and then you can connect to it from there. And that hash table, when you first join that hash table, you join through a couple of, it's decentralized, but there are a couple of centralized locations that you connect to, and from there you discover the rest of the network, if that makes sense. But that hash doesn't actually map back to a machine. It maps back to a torrent file that you, like, I want to download this torrent file, and then from there you use that hash to identify the other users who have that file on that, so that lets you search for it. And then once you download the file, you can use that hash to verify the pieces that you've downloaded and make sure that they're the right pieces, if that makes sense. Right. That's a very good question. So actually one of the easiest ways to demo this is to look at that. Development / decentralized talk, yeah. Oh, wrong file, Demo.js. So if we look at this magnet file, there's not really that much interesting going on here because there's only one file. But the way this works is the torrent will actually break all the files. So it actually breaks the entire blob, the torrent, up into a bunch of tiny little chunks and hashes each one. Our file was already a tiny little chunk by itself. So you can see that there's the hash of that file. And what you do is on the network, you request the individual chunks. And then you find the peers that have those chunks, and then you download that chunk, and you download the entire chunk. And then once you have the chunk, you reassemble it. You take the hash of that to verify that it's the actual chunk that you were looking for. And as long as it verifies that, or like satisfies that requirement, you drop it in place in the file. And then you download all the tiny little pieces at a time. And that's actually how WebTorrent works when you decide you're going to stream something. So there's actually, a good way of visualizing this is the WebTorrent desktop app. Internet's failing me, or my browser's failing me, one of the two. Anyways, the WebTorrent desktop app, you can actually download like video, or download and stream video like live, and it's pretty fantastic. You download a torrent that has a video in it, you click play, and it starts prioritizing those tiny little pieces at the beginning of the file. So it downloads those with higher priority, so it downloads those quicker and faster than the rest of the file, so you can actually start streaming from the beginning before the rest of the file is downloaded, if that makes sense. So it's not really a lookup. So the hash maps to the file, or to the chunk itself, right? So that hash maps to the chunk. So this hash, from my understanding, this hash maps to the torrent file hash. So like when you first generate a torrent, you generate what's called a torrent file, and that has all the chunks along with all of the chunks hashes. And then if you take the hash of that, you get this, so it's hashes all the way down. And then when you request that, hey, I want to download this thing from the network, you publish this hash. And then it says, hey, somebody has this thing over here, and you download that torrent file, and that torrent file has the hashes for all the other pieces. And then you know that that torrent file and the pieces inside of there that it references are the right ones because it matches the original hash. And then you start requesting the hashes out of the torrent file. That may be entirely wrong, but that is my current understanding of how this works. Yeah. If you guys want to play around with this, please do. Download PeerWeb. It's very, very early stages, and there's a lot of things wrong with it, and I would like somebody else to tell me what those things are so I'm not chasing wild geese. Yes. Cool. Thanks, guys.